Question 4, Part B. Let f of x equal the square root of 25 minus x squared. Part 1. Copy the following table of values into your writing booklet and supply the missing values. When x equals 1, f of 1 is equal to the square root of 25 minus 1 squared, which equals 4.899. Correct the 3 decimal places. Now when x is equal to 3, f of 3 is equal to the square root of 25 minus 3 squared, which equals 4.000. And when x is equal to 4, f of 4 is equal to the square root of 25 minus 4 squared, which equals 3.000. Part 2. Use these 6 values of the function and the trapezoidal rule to find the approximate value of the integral of the square root of 25 minus x squared dx from x equals 0 to x equals 5. To save time, we can use the extended trapezoidal rule where h is equal to 1. Now h is the difference between any two consecutive x values. For example, the difference between 3 and 2 is 1. We can also think of h as the common difference in this arithmetic sequence, 0, 1, 2, 3, 4, and 5. So the integral of the square root of 25 minus x squared dx from x equals 0 to x equals 5 is approximately equal to h over 2, or 1 over 2 times open bracket 5 plus 2 times 4.899 plus 2 times 4.583 plus 2 times 4 plus 2 times 3 plus 0 close bracket, which is equal to 18.982. Part 3. Draw the graph of x squared plus y squared equals 25 and shade the region whose area is represented by the integral of the square root of 25 minus x squared dx from x equals 0 to x equals 5. The graph of x squared plus y squared equals 25 is a circle centered on the origin with radius 5 units. Now we get the radius by taking the square root of 25. This means the circle cuts the x-axis at 5 and negative 5 and the y-axis at 5 and negative 5. Now if we take the equation of this circle, x squared plus y squared equals 25, isolate y squared by subtracting x squared from both sides of this equation, we get y squared is equal to 25 minus x squared, and then taking the square root of both sides of this equation, we get y is equal to plus or minus the square root of 25 minus x squared. Now if we graph this, we'll get a circle centered on the origin with radius 5 units. Now if we consider the positive square root of 25 minus x squared, we get the positive semicircle. That is the part of the circle that's on or above the x-axis. Now the region that we're asked to shade is represented by the integral of the square root of 25 minus x squared dx. So that's the positive semicircle. However, it's from x equals 0 to x equals 5, not from x equals negative 5 to x equals 5. So we're only shading in half of the positive semicircle, and the particular half that we're shading in is in quadrant 1. Part 4. Use your answer to Part 3 to explain why the exact value of the integral is 25 pi over 4. The area of the shaded region is equal to the area of a quarter circle of radius 5 units. And the area of a circle is given by pi times 5 squared, so that's pi r squared, and we divide that by 4 to get the area of the quarter circle. And that's equal to 25 pi over 4. Hence, the exact value of the integral of the square root of 25 minus x squared dx from x equals 0 to x equals 5 is equal to 25 pi over 4 as required. Part 5. Use your answers to Part 2 and Part 4 to find an approximate value for pi. From Part 4, we know that the exact value of the integral of the square root of 25 minus x squared dx from x equals 0 to x equals 5 is 25 pi over 4. and that's approximately equal to 18.982 using the result that we obtained in part 2 using the trapezoidal rule. So to find an approximate value for pi, we treat pi as an unknown variable, and then we solve for pi the equation 25 pi over 4 is approximately equal to 18.982. We can isolate 25 pi by multiplying 18.982 by 4, and we get 25 pi is approximately equal to 75.928. We isolate pi by dividing 75.928 by 25, and that evaluates to 3.03712. Therefore, pi is approximately equal to 3.03712 using the results from parts 2 and 4.